Assalamualaikum and good afternoon to my respected chairman and all of you. My name is Muhammad Aizuddin bin Abdullah, PhD student from University Malaysia Pahang. Today, I would like to present my paper under title Investigation of Pipe Material and Thermal Conductivity of Soil on the Performance of Ground Heat Exchanger Operating under Malaysia Climate. I will go to the introduction. Nowadays, human population is increased and development of the country improve from time to time. Therefore, the requirement for space thermal comfort also will increase during summer and winter. Air conditioning and heat pump is widely used for space thermal comfort. However, the use of air conditioning and heat pump will be depleting of the ozone layer, global warming, and increase the energy consumption. Thus, there is need an alternative to reduce energy consumption and to protect the environment. Therefore, GHE system is the one of the alternative technique to reduce the energy consumption and to protect the environment. There are many advantages of GHE system which is they consume less energy to operate, they have lower initial cost, they do not require the unit to be located where it is exposed to weathering, they do not use compressor, CFC or any refrigerant that will deplete the ozone layer. Air uses as working fluid in GHE. They have a simpler design and consequently less maintenance, and it is expected that air pollution problems will be minimized by using GHE for passive cooling and heating purpose. Due to the increment of energy consumption by using the air conditioning and the heat pump system, it will consume a more energy for the future. Thus, GHE system for space thermal comfort has been studied, so the performance of the GHE is depend on a few factors such as geographical factor, ambient temperature, depth of ground, and ground thermal properties. Therefore, in this paper, I want to focus on the thermal properties of the ground with specific pipe material for better performance in terms of effectiveness based on simulation method. Therefore, I already derived one objective in order to accomplish of the work, which is to investigate the effect of the pipe materials and thermal conductivity of soil to the performance of the GHE. Now we move to the literature review. During summer, the hot outdoor air is sent into the GHE pipe. When air flows in the GHE pipe, heat is transferred from the air to the earth. As a result, the air temperature at the air outlet of the GHE pipe is much lower than the temperature of the ambient. During winter, the cold outdoor air is sent into the GHE pipes. When air flows in the GHE pipe, heat is transferred from the earth to the air. As the result, the air temperature at the air outlet of the GHE pipe is much higher than the ambient temperature. A few researchers say that the refrigerant and air conditioning system consume about 50% of the total electricity consumed all over the world. It is expected that the number of air conditioning systems will increase from 1.6 billion to 5.6 billion by 2050, which will increase the power requirement for air conditioning almost 3 times. Now, I will go to the methodology part. First, apply the mathematical model of GHE and then carry out the simulation by using Excel software. The air temperature will be recorded. If not, then go back to apply mathematical model. This is due to equation error, and if yes, then proceed to the data analysis based on two parameters, which is pipe material and soil thermal conductivity. This is the schematic of heat transfer process in GHE pipe. From this schematic, a equation has been generated, and the equation has been used in simulation. This table shows the physical thermophysical and thermoparameter used in simulation to investigate the effect of pipe material and thermal conductivity of soil on the GHE performance. There are five pipe materials with different thermal conductivity, which is PVC, HDPE, stainless steel, aluminum, and copper were considered in this simulation. Meanwhile, five different of thermal conductivity of soil that has been used in this simulation. This table shows the condition of all the pipe materials and its surrounding for the input of the simulation. Simulation is conducted based on same pipe diameter for all pipe material with 25-meter length. Besides, the velocity of air flow rate, ground temperature, and air inlet temperature also set to be constant in this simulation. The thermal conductivity value of the ground is considered as homogeneous. Now I will go to the result and discussion. Table this table shows the output air temperature of GHE for pipe, 4 PVC pipe and 5 different of soil thermal conductivity. The data was recorded from 0 to 25 meter length of pipe with increment of 1 meter. Meanwhile, other material of pipe material are HDPE, stainless steel, aluminum, and copper were analyzed same as PVC pipe material. This figure shows the pipe length against air temperature for 5 different of soil thermal conductivity. From the graph, the same trend has been obtained throughout length against air temperature for all pipe material. However, their air temperature is different for all pipe material at the same thermal conductivity of soil. This is due to all pipe material has different thermal conductivity. Regarding the thermal conductivity of soil, the variation of air temperature decreases along the length of pipe from 0 to 25 meter as the thermal conductivity of soil increase for all pipe material. The thermal conductivity of soil range from 0.5 to 1.5 volt per meter Kelvin has significant effect on the air temperature drop along the line of pipe for all pipe material. In the meantime, the thermal conductivity of soil from range 1.5 to 10 volt per meter Kelvin has no significant effect on the temperature drop along the length of pipe for all the pipe material as shown in this figure. Therefore, it can be concluded that the good range of soil thermal conductivity was between 1.5 to 10 volt per meter Kelvin. This figure shows that the graph of pipe length against air temperature for all pipe material at constant thermal conductivity, which is 10 volt per meter Kelvin. By referring this figure, HDPE pipe material give more significant effect compared with PVC pipe material, while stainless steel, aluminum, and copper pipe material gives larger effect to the performance of GHE system compared with HDPE and PVC pipe material. This variation happens due to the difference of thermal conductivity of pipe material. However, stainless steel, aluminum, and copper pipe material give almost the same performance. Even the copper pipe material have the highest thermal conductivity compared with stainless steel and aluminum pipe materials. Therefore, this analysis can be concluded that the pipe material does not give significant effect to the performance of GHE system, which similar with previous study. So the conclusion is the influence of the pipe material and thermal conductivity of soil to the performance of ground heat exchanger system has been determined by simulation study. There are 5 different types of pipe material, which is PVC, HDPE, stainless steel, aluminum, and copper with different of thermal conductivity. Meanwhile, there are 5 different of soil thermal conductivity that has been used in this study, which is 0.5, 1.5, 2.5, 5, and 10 volt per meter Kelvin. The soil thermal conductivity from 1.5 to 10 volt per meter Kelvin is the good range of the performance GHE system. The pipe materials do not give significant effect to the performance of GHE system. Even the thermal conductivity of the pipe material is lower. Low cost of pipe material can be used in GHE system instead of high cost pipe material. Besides, the optimal length of pipe is about 10 meter for PVC pipe material at range 1.5 to 10 watt per meter Kelvin of soil thermal conductivity. Thank you.